Okay, this video we're going to look at work done. Work done is a measure of how much energy has been transferred. It's not a type of energy like kinetic or potential or sound. It's a measure of how much energy has been transferred from one type of energy into another. So it's still measured in joules. Now, anytime we want to transfer energy from one type to another, we need to apply a force over a particular distance. So we use this equation here to calculate work done, which is work done equals force times distance. That should look slightly familiar in that it's the same equation almost for moments. Moments equals force times distance. The only difference here is, and it's a very subtle difference, is work done is the force times the distance moved in the same direction as the force. And if you're asked to write down the equation, you should write that down. It's okay using this equation here when you're calculating things, but if you're asked to write it down, I would write it down as it is on the screen at the minute. Moments is equal to the force multiplied by the perpendicular distance from the pivot. The distance in work done has to be parallel. So let's look at a little example here. So we have a car whose engine is producing a 600 Newton force, and we're being asked how much work is done over the 2 kilometre straight. And all we do is we use the equation work done equals force times distance. We check that the force and the distance are parallel. We then put in the force 600. The distance has to be in meters, so I'd multiply that 2 kilometers by 1,000, and that will give us 1,200,000 joules of work. Now, if everything's 100% efficient, that'll be 1,200,000 joules of chemical energy in the fuel getting changed into kinetic energy in the car. Let's look at a second example. So here we have a person who is going to walk up this mountain or hill that's 200 meters high, and the person has a mass of 50 kilograms. We want to use work done equals force times distance, and the force has to be in the same direction as the distance. Now, we don't have a force, we have a mass, but we can work out a distance by a force by using mass times gravity. Gravity on Earth is 10, which means his weight is 500 newtons. So if he wants to climb up something, he's going to need to apply a force as big as 500 newtons upwards. I know that he might actually walk up the slope in that direction, but that doesn't matter. We want a force that is parallel to a distance, and we can multiply those two numbers together. So we get that the work done is 500 times 200, which tells us the work done is 100,000 joules, and that would be from chemical energy in the food that he's eating to gravitational potential energy at the top.